Hello. Today we are taking a small detour through chapter 6 on arrays. The reason we are taking this small detour is that knowing the very basics of arrays will be helpful when we start using loops. So we're going to get into this chapter into full detail a little later, but for now I just want to introduce you to the basics of arrays. So arrays are simple data structures. There are other data structures besides arrays. Again, that we'll get to closer to the end of the course. So an array is a group of contiguous, meaning memory locations right next to each other, contiguous memory locations of the same type. So basically, you can think of it as a set of variables of the same type that are located in memory right next to each other. And an element of an array is specified by the name of the whole of the array of all elements, containing all elements, and the position number of the specific element you want to access. So in the next figure, we'll look at an array called C, named C, that contains 12 elements in all. As you will see, the array name looks just like any other variable name. Naming conventions for arrays have to follow the same naming conventions, the same limitations as variable names. The specific element or position number of an element is specified using these square brackets. Here's an example. Here's a figure that shows what an array can look like in memory. So over here, this is an integer array called C, and it contains, its size is 12 elements. This is how I would define that in my code. The first element that you can see at the top over here is referred to as C0. 0 is the index number of the element. The first element of an array is always assigned or always gets the index number 0. So counting in C starts at 0. And of course, I told you that the size of this array is 12 elements, which means if we start counting at 0, the index number of the last element will be 11, one less than the size of the array, one less than the number of elements in the array. This is an integer array, and we can tell and confirm that by looking at all the numbers, all the values assigned to each array element. And as you can see, they're positive and negative integers, all of them. So like I said, the first element is also called the 0th element. So technically, when I was saying the first element, I guess I should say 0th element. Now that you know that indexing in C starts at 0. Already said that the naming conventions for arrays are the same as for variables. The position number is also called index or subscript. And the index number or the element number that you provide to access one element in an array must be an integer or can be an expression that evaluates to an integer. So for example, over here, still considering the same array C that we just saw, if we have a variable A equal to 5, another integer variable B whose value is 6, we could write this statement in our code, and what this would do is, first of all, A plus B evaluates to 11. So this entire left-hand expression evaluates to C11, and this might seem a little confusing. This is basically shorthand for C11 is equal to C11 plus 2. So what this statement does is it adds 2 to element 11 to the 11th element of array C. So like I said, the array's name in this example is C. It has 12 elements, and you can refer to each element as C0, C1, C2. You can use these just like you are using variables in your code, right? All the way up to C10, C11. And in this example over here, we saw that C0 contains the value minus 45, C1 contained the value 6, minus 45, 6, then we have 0, 72, 1542, 1543, and so on. So we could just as easily print out the sum of the first 3 elements of the array using this statement. So you can print out in decimal format the sum of C0, C1, and C2, the first 3 elements of array C. If, as another example, if you want to divide the value of element 7 of array C by 2 and assign the result to variable x, you would write x equal to C7 divided by 2, assuming x has already been defined. Small detail that the square brackets that are being used in arrays are treated as operators. And as operators, they have to be put into an order of precedence. They have to fit into the order of precedence. So we've already seen the order of precedence of different operators before. We're now adding to it square brackets. And these have the highest order of precedence, meaning these are the first symbols to be evaluated. Now, arrays, as we have seen, occupy space in memory. When you're defining an array, you have to specify the type of elements it's going to contain. They all have to be the same, of course, and you have to specify the number of elements, the size of the array. Once you define an array, you cannot change its size later on, at least not the arrays that we're looking at right now. These are called static arrays, meaning once you create them, define them, create them, once the memory is allocated, you cannot add to it or remove from it. So like I said, to create the array C we have seen above, we would write this statement: int c, and in brackets, the size of the array, the number of elements it should contain. C12 means, of course, that the valid range of indices will be from 0 to 11, one less than the size. Just like variables, you can define multiple arrays in a single line of code. So consider this example over here. What this will do is this will define an array B. First element will be B0, followed by B1, all the way to last element B99. And second thing, part over here will create an integer array X, first element X0, second element X1, or I should say 0th element X0, first element X1, and last element X26, because the size of array X is 27. Now, so far, all the examples that you've seen were of arrays of type integer, but you can make arrays of other data types as well, meaning floating point numbers, double precision floating point numbers, characters, etc. We also have a special name for arrays of characters. Call them strings. And we'll talk more about strings because there's some peculiarities about strings, some other things you should know about strings that we'll cover later in chapter 8. So for the moment, this much information about arrays is enough for us to work with slightly more interesting and even useful examples of loops.